Superatom.
Disclaimer: Superatom is not a Marvel or any DC or any other superhero character.
Superatom is a physics hero.
Before we get going into our adventure, we need to know what is exactly nuclear physics. Nuclear physics is the study of the atomic nuclei and its interactions. Before we start with our adventure with superatom and nuclear physics, we need to learn more about the nucleus and its composition. So as we can see here, we can see the electrons that orbit around the nucleus, and the nucleus that is the most dense part of the atom and holds about 99.99% of the mass of the atom. Now let's go deeper into the atom. The nucleus of any atom consists of protons and neutrons. Protons are positively charged, while neutrons are electrically neutral. Both protons and neutrons have relatively the same mass, and because they are both found in the nucleus, we call them nucleons. We have two types of transportation: artificial transportation and natural transportation. And from the names, you could tell that artificial transportation happens from a factor from the outside, while natural transportation happens without any help from the outside. Radioactivity is the spontaneous emission of radiation by unstable nuclei to become stable. It attains stability by the emission of alpha particles, beta particles, or gamma rays. Now let's talk a little bit about these different radiations. First, we have the alpha particles. Alpha particles have a really low penetrating power, which can be stopped by 7 centimeters of air or a piece of paper. Alpha particles are the nuclei of the helium atom, having 2 protons and 2 neutrons. If entered into the body, alpha particles would be really hard to get out and they cause really major mutations in the DNA genes and the cells of the body. In alpha decay, a helium nuclei is produced and the atomic number is decreased by 2 while the atomic mass is decreased by 4. Now, after we're done with alpha particles, let's talk about beta particles. Beta particles are very high-speed electrons or positrons that are ejected during a nuclear decay called beta decay, which occurs when a nuclei has too many neutrons and wants to achieve stability. Beta particles are less ionizing than alpha particles, which means they would do less damage. Getting exposed to beta particles can cause burn like severe burns, and they have higher penetrating power, meaning they could easily penetrate into the skin. They can be easily stopped by an aluminum plate or a sheet of plastic. In beta decay, a neutron decays into a proton, emitting an electron and an antineutrino. The atomic number increases by 1, while the atomic mass stays the same. Now, after we're done with beta particles, we can now move to gamma rays. Gamma rays have no mass or electric charge, so that they can move in their speed of light. They would need to travel thousands of meters in air to spend all of their energy. Gamma rays have very high penetrating power. Simple normal gear clothes for air shielding would not be protective enough. You would need to have really thick steel or concrete or lead to be able to stop gamma rays. Gamma decay occurs when some unstable atomic nuclei releases excess energy by a spontaneous electromagnetic process. In this process, gamma rays, which are photons or packets of electromagnetic energy, are radiated. As you saw from the decades that we saw above, you can see that the atom before going through nuclear decay was called parent atom, while the atom after it went through nuclear decay, it was called a daughter atom. Now, let's go to artificial transmutation. Artificial transmutation is the conversion of one element into another by artificial means. This means, for example, a scientist would bombard an atom with a particle like alpha particles or a neutron to form a new element. We have two types of artificial transmutation: fission and fusion. Fission occurs when a neutron hits a larger atom, forcing it to split into 2 smaller atoms. This process could cause also additional neutrons to release that would initiate a chain reaction. When this atom splits, a tremendous amount of energy is released. Chain reaction is when neutrons released from a fission process hit other atoms and causes them to also undergo fission. We have two types of chain reactions, controlled reactions and uncontrolled reactions. Now, controlled reactions is a chain of nuclear reactions that take place under controlled conditions. For example, in power plants, they must control the reactions, and usually with heavy water, so that it doesn't produce huge amounts of energy that would cause an explosion. Now, the uncontrolled reaction is vice versa. It's a chain of nuclear reactions that take place under no controlled conditions. These reactions produce huge amount of energy and is the process used in atomic bombs. Uranium-235 is the only atom that can perform fission. Although uranium has 8 isotopes, which are uranium-233 to uranium-239, uranium-235 is the most active of them all and the most unstable. During uranium fission, a slow neutron enters the nucleus of uranium-235, which causes it to be highly unstable and become uranium-236, which has a life of few seconds. When it changes the shape of the nucleus into a dimple, Coulomb forces work to break the nucleus into two. The nucleus releases an energy of 200 million electron volt, which is because of the binding energy that kept the nucleus intact. 20% of fragments are possible to be produced by this process. Now let's talk about fusion. Fusion occurs when two light atoms bond together to form a heavier one. The total mass of the product atom won't be equal to the total mass of the reactant atoms, and that's because some of the mass of the reactant atoms are converted into energy after binding. This is described by Einstein's famous equation, which is E = mc squared. Fusion only happens in the sun, because it needs high pressure and high temperature to occur. Fission reaction releases much more energy than fission reactions do. Also, fusion reactions cannot be controlled and have no radioactive byproducts. So now let's put nuclear fission and nuclear fusion side to side and compare them. Fission is a splitting of a large atom into two or more smaller ones, while fusing is the fusing of two or more lighter atoms into a larger and a heavier one. Fission doesn't really occur in nature, while fusion occurs in stars such as the Sun. In fission, the products have less mass than the reactants. When nuclear fission, the product has a greater mass than the reactants. It takes little energy to split the two atoms in a fission reaction, while it takes extremely high energy and pressure to bring two or more protons close enough in a nuclear fusion. In nuclear fission, the energy released is millions times greater than the release in chemical reactions, while in fusion, the energy released in fusion is 3 or more times greater than the energy released by fission. Although they have so many differences, both nuclear fission and nuclear fusion have similarities. Both of them use the energy stored in atomic particles. Both of them are processes that aim to produce energy. And also both of them are reactions that are suitable for making nuclear bombs. Of course, with no doubt, most of us have heard about the atomic bomb that struck Hiroshima, and was a tragedy noted in history. But now knowing that there are two types of nuclear bombs, do you know which one was it? Was it fission or was it fusion? And what's the difference between these two? Let's check it out together. Now, of course, if you have done some research beforehand, you would know that the bomb was a fission bomb, which is a good thing, you could say, in one part, not by that degrading the event itself, but knowing that a fusion bomb, or hydrogen bomb as it is called, would have caused much more damage than it already did. Alright, so now let's go to the differences. First, atomic bombs, as we said, uses fission, while hydrogen bombs, as we said too, uses fusion. Second, hydrogen bombs are 1,000 times stronger and more destructive than atomic bombs. Third, atomic bombs use uranium-235 or plutonium, while hydrogen bombs use deuterium or tritium. And that's our wrap up with Superatom and her adventure with nuclear physics. Hope you enjoyed and of course learned something new. Have a good day, see you next time with more adventures.